Hello everyone, welcome back. So in today's video, we'll take up two problems from Pathfinder. And these two questions are from the chapter rotation. Okay, so in the first question, we have a disk whose radius is capital R, and it is rolling on the inner surface of a stationary coplanar ring whose radius is double. So basically, the outer disk is a fixed disk, okay, and the inner one, which has half the radius, is said to roll on the inside of this outer disk. If speed u of the center C of the disk is a constant, write coordinates of the point A of the disk as a function of time at instant t equal to 0. The point A is in contact with the ring as shown in the figure. Okay, so we have to find the coordinates of the point A. And this point A is basically this point on the rim of the inner disk, and initially it is in contact with the outer disk. Okay, so yeah, let's start by drawing a diagram. Okay, so this is the diagram of the situation. So it's given to us that the center of this disk moves with a constant velocity of u. So let's call the center of this disk as C and the center of the bigger disk as O. So now let's just rotate the line CO by some angle, let's say theta. Okay. Okay, so the disk finally comes to a point somewhere over here. Okay, and we'll hide the initial location of the disk by using these dotted lines. Okay, so once again, initially the point C was somewhere over here, and finally it's going to be somewhere over here, right? So we basically rotated it clockwise by some angle theta. Okay guys, so now the thing is, if you want to move the cylinder center in the clockwise direction, then obviously you'll have to roll it in the counterclockwise direction, right? So let's say it rotated. So let's say the cylinder rotated by some angle phi about its own axis. Okay, so just for a little bit of visualization, what we can do is, in the initial position of the disk, let's choose some point B, okay, and let's connect it with the line C. Okay, now if the cylinder was just translating, picked up this cylinder and we placed it over here, then what would happen is the line CB will not change its orientation. So let's say this angle with the vertical was 15 degree, for example. Then in the final situation also, this angle would be 15 degree. Okay, and this is basically the definition of translation, right? You just pick this thing up and you place it over here. Okay, but the thing is, this is not just translation, right? It is translating and rotating at the same time. So if we assume that it rotated by some angle phi, okay, for this specific example, let's say phi is 15 degree. So if we say the cylinder rotated counterclockwise by 15 degree, now this line BC would have rotated by 15 degree, and now the point B would have come right under the point C. Okay, so basically what I'm trying to say is, we can break down the motion as translation plus rotation. Now let's get rid of the point B and check out what happened to point A. Now point A, guys, if you observe, was initially over here, right? So basically the line AC, if you observe, is horizontal. So let's do the trick again of translation plus rotation. So if I just pick this thing up and place it over here, the line AC must be horizontal, right? So let me draw a horizontal line here. Okay, so this is the horizontal line passing through the center. So if it was just translation, the point A would have been over here on the rim. Okay, but as the cylinder itself rotated by an angle phi, the line AC will also rotate by an angle of phi. So the actual position of A, so if we rotate it by an angle of phi, this will be the actual position of A. Okay, so once again, initially the line AC was horizontal. Okay, which means if we just translate it, AC will be horizontal, and then we added the rotation step, and now we rotate AC by the same angle phi, and now the point A is over here. Okay, so now we have to write down the coordinates of A. Before we do that, let's relate. We can actually do something to relate this angle phi and this angle theta. So let's try to do that first. For that, what we'll use is, we'll use the rolling condition. So okay, so to satisfy the rolling condition, we just have to find the net velocity at the contact point and make it equal to 0, right? So for that, we can use the center of mass. So we know the center of mass is, we know the velocity of the center of mass, right? So now relative to the center of mass, we'll observe pure rotation. So let's say the contact point is some C. So the velocity of C is going to be velocity of the center of mass plus velocity of c with respect to the center of mass, right? So now the velocity of center of mass we know, right? It's u perpendicular to the line co. And with respect to center of mass, we'll only observe pure rotation, right? With an angular velocity of, let's say, omega. So basically c will be like a hinge about which all the points will be performing a circular motion. And so with respect to the center of mass, the velocity of the contact point, we can write it as small r omega, where small r is the radius of the smaller disk. Okay. Now, what is this omega? This omega is the rate at which this angle phi is changing. So basically, the faster the angle phi changes, the larger is the value of omega. So earlier in the case of pure translation, we saw that the line AC was horizontal, right? So the angle phi wasn't changing. So in that case, omega is 0. Okay, so that's the definition of pure translation, right? So that is basically it doesn't rotate. So here, so basically the omega is nothing but the rate of change of the angle phi, first of all. Okay, so now the velocity of the contact point with respect to the center of mass, we know it is going to be r omega in this direction as I marked. And now the velocity of the center of mass, we know it is u perpendicular to the line CO. So we'll have to vectorially add it to the contact point to get the velocity of point C in the ground frame. Okay, so from here u has to be equal to small r omega, or we can also say it is r d phi by dt if we want to express in terms of phi. Okay, so from here the omega of the rigid body, we get it as u divided by small r, which is actually u divided by capital R by 2, right? Because it's given to us that the radius of the green disk is half the radius of the pink disk. Okay, and omega, once again I can write it as d phi by dt. Okay, so now let's try to calculate d theta by dt. So theta, once again, is the angle made by the line CO with the horizontal. D theta by dt, which is the rate at which it changes, we can easily figure out. So the perpendicular velocity of the point C is u, and that divided by the distance CO will give us the omega of this line, right? So d theta by dt will be u divided by, again, the same distance r by 2. So even this will be 2u by r, but vectorially they're opposite in direction, right? Omega is counterclockwise, whereas d theta by dt is clockwise, but magnitude wise they are the same, right? So now if you compare these two equations, we come to a very important idea. That is, a magnitude of d phi by dt is the same as the magnitude of d theta by dt. So okay, so if you cancel out the dt's, then you can see magnitude of d phi is the same as magnitude of d theta. Okay, so this we can basically just integrate on both sides, and we can say delta phi is equal to delta theta. Okay, so what this is trying to say is, when I rotate this line CO by an angle of theta clockwise, this angle phi that the rigid body rotated by about its own center of mass, they both will be the same in magnitude. Okay, so that is what this equation is saying. So in short, if this angle is theta, then this phi will also be theta. This angle, we can also say it is theta. Okay, so the last diagram got a bit crowded. So once again, the point A was over here initially. So finally, we just said that if it was just translation, A would have been over here, but that's not the case here. There is a rotation, and the disk rotates in the counterclockwise sense by an angle of theta, right? So this angle over here is theta. The thing is, guys, if you so this is something geometrical. If you observe, so this length over here is r by 2. So if you observe this height, this perpendicular that I dropped onto CO, its length is r by 2 sine theta, right? So now if you observe this length, right, this perpendicular also is r by 2 sine theta in magnitude. So which basically means the diagram is a bit incorrect. The point A will also be in the same horizontal level as CO. Okay, so basically even this angle is going to be theta. Now it looks like A and C actually coincide, but that's because of the diagram, right? A is at a different distance from O as compared to C, right? So from this diagram, we see an interesting result, right? A actually lies on the x-axis itself, right? So this is because of the reason that the rotation, the theta rotation and the phi rotation are actually equal and opposite. So Okay, so when we rotated the line by an angle of theta, the line AC rised up by r by 2 sine theta, and then because the rigid body rotated counterclockwise by the same angle theta, the point A went down by the same amount of r by 2 sine theta, and finally it ended up in the x-axis itself. So so its coordinate from this diagram we can see it is, so this rightward direction was the positive x-axis. So its x coordinate is 2 times r by 2 cos theta, but with a negative sign, right? Because it's towards the left of O. And its y coordinate is 0. Now theta is a variable that we chose, right? So we'll eliminate it. D theta by dt, we know it is u divided by r by 2. So theta, we can write it as 2u by r multiplied by the time t, right? So the x coordinate of point A becomes minus 2 minus r cos of 2 ut by capital R. Okay guys, so I made a slight mistake. So the radius of the larger sphere was 2r and the smaller one was capital R. So basically we'll multiply everything with 2. So we'll just have to multiply this with 2, right? Okay, so that will yield the answer minus 2r cos of ut divided by r. So the point A is going to be performing an SHM in the x direction, basically. So yeah, that was the answer to this question. So now let's move to the next one. Okay, so the questions. So this is question number 5 from the check section. So a square lamina ABCD with one of its flat face on a horizontal floor is sliding on the floor. Okay, so basically a square is sliding on the floor, and we have an instant velocity, and it's given that at an instant velocity vectors of corners A and B are perpendicular to each other, and the corner C is moving with a velocity V at an angle with the vector CD. Okay, so we have to draw a diagram to make sense of this. Okay, so the angle that it makes, the tan theta of it is given to be 0.5. Find the velocity of the midpoint P of the side AB at this instant. Okay, so we have a square that is given to be sliding on the floor. So let's say this is A, B, C, and D. Now velocity vectors of corner A and B are perpendicular to each other. Okay, so that itself directly implies that the square is also rotating. Okay, because otherwise the velocity vectors of all points will be parallel. So yeah, VA and VB are perpendicular to each other, and the corner C is moving with velocity V at an angle with vector CD, tan of which is 0.5. Okay, so basically VC is going to look something like this, right? And let's say this angle is theta. So they're saying tan of theta is basically 0.5. So theta is I mean, you can determine theta if by just calculating tan inverse of 0.5. So that theta is a known quantity. Okay, and the speed Vc is given to be V. So we have to find the velocity of midpoint of AB, which is this particular point over here. Okay, so now one info is given to us, that is velocity of A and B are perpendicular to each other. Okay, so now as it is a problem of combined translation and rotation, if we can figure out the instantaneous center of rotation, we can write the velocities of each point pretty easily. So that is the direction in which we should be thinking. So we have information about one direction, right? This velocity vector V. So we can draw perpendicular over here. So before we do that, let's get an idea of this angle theta. So tan theta is 0.5, which means theta is clearly less than 45 degree, right? So which means a perpendicular line will look something like this. And let's extend it to the other side as well. Okay. So this is the perpendicular to the velocity vector VC. Okay. So basically even this angle is going to be theta. And yeah. Now let's say the side of the square is A. Here, if you observe this right triangle, guys, A tan theta, A multiplied by tan of this theta gives you this distance, gives you the other side of this right triangle. Okay, but tan theta is 0.5, which means this side is half of A, which also means that this line will pass through the point P, which is a pretty interesting result. Okay, so now let's just finally assume that the velocity of A is in some direction, making an angle of alpha with the horizontal with AB. So from here, the velocity of B will make an angle of alpha with the side BC, right? Because, okay, so this is pretty easy to understand. You can just extend this line. The velocity of A is along this line, and this angle is alpha. So this is 90 minus alpha. This will be alpha. Okay. So this ensures that A velocity of A and B are perpendicular. So what we did is we assume some direction for the velocity of A and the velocity of B. Okay. So, and we also know that the angle between the velocity vectors is 90 degree. So which means if I draw a perpendicular from these two sides, obviously the intersection should give us the IC. This angle must also be 90 degree, right? Okay, so basically I drew perpendicular to velocity of B and the velocity of A, and we know that they should intersect along this line, because we know the instantaneous center of rotation lies on this line PC, which we drew initially, right? So from here we actually got the instantaneous center, and we also know that this angle must be 90 degree. So here there is another very interesting geometrical result. So if you observe, this angle is 90 degree, right? So basically if I draw a semicircle whose diameter is AB, then the IC actually lies on it, right? So that's the 90 degree angle property, right? So this is a property of circles. So if you basically draw two lines from A to any arbitrary point and B to the same point, the angle intercepted will be 90 degree, right? So what that means is this length PIC, PB, and PA, they are all equal, right? Equal to the radius of the circle, and all these lengths are A by 2. So this length PIC is also A by 2. So now we know that the velocity, once we know the IC, all we have to do is omega into R, where obviously R is the perpendicular distance to the point from the IC, right? The only information about the velocity given to us is the velocity of point C. So now the distance PC, we can figure it out. It will be A upon cos theta. How did I write this? I used this right triangle. We know this side is A and this angle theta. So it will be A upon cos theta, the length PC. So tan theta is half. So this is going to be root 5. So A upon cos theta would be 2 by root 5. So this is root 5 A by 2. So the length CIC is going to be root 5 A by 2 minus A by 2, which is root 5 minus 1 A by 2. So now we know this particular distance. So if I multiply that distance with the omega of the rigid body, so this rigid body was initially rotating with some angular velocity. So that angular velocity times the distance should give us the velocity of point C. So from here we get omega as 2v divided by root 5 minus 1 times A. Okay, and now once we have the velocity, the question is done, because the velocity of point P is just going to be omega multiplied by A by 2. So you can also represent its direction. It will be perpendicular to the line PIC. So the velocity of point P is going to be 2v by root 5 minus 1 into A times the distance, which is A by 2. So this gives the answer as v divided by root 5 minus 1. So if you rationalize this thing, it will be root 5 plus 1 v divided by 4. Okay, so this is one of the answers. Okay, there are actually two possibilities for this question. This is actually one of the answers. Now, why is there another possibility? So I'll explain by drawing the same picture once again. Okay, so guys, initially to start with, we figured out that the instant center should lie along the line PC, right? And another constraint was that this angle must be 90 degree. So basically if you connect IC to B and IC to A, this angle should be 90 degree. But it says nothing that IC has to be on inside the square, right? It can be outside the square as well. So another point which satisfies both the constraints that we just discussed is the point somewhere over here, which is exactly the distance of A by 2 from P. So let's try to draw that point. So if I extend this line, and give it some thickness, this can be another location for the IC as well. If I say IC dash P, distance is A by 2, then once again I can ensure that this angle is 90 degree, right? So yeah, the situation can be like this as well. And here if we observe, so here in this case the velocity of A will be perpendicular something like this, and the velocity of B will be in a direction something like this, such that it is perpendicular to the line connecting IC to that point. Okay, so this is the second possibility where the IC actually lies outside the square. So here also we'll take the same information that the velocity of point C is V. So what is the distance C to IC dash? So this distance is A by 2, right? And the distance PC we figured out in the last page. It was A root 5 by 2. So the distance from IC dash to C is root 5 A by 2 plus A by 2, which is actually root 5 plus 1 A by 2. Okay, so now VC is given to be V, which is equal to the omega multiplied by root 5 plus 1 A by 2. So from here the omega turns out to be V divided by root 5 plus 1 A divided by 2. And now all we have to do is multiply by the distance IC dash P to get the velocity of point P. Okay, so now basically the velocity of point P will be omega times A by 2. So this if you do, you'll get the answer as root 5 minus 1 V divided by 4. So the two possibilities are root 5 minus 1 V by 4 and root 5 plus 1 V by 4. So yeah, that was the solution to this question. So if you guys have any doubts, you can comment down below. And yeah, if you enjoyed the video, please do like, share and subscribe. And that's it. Thanks for watching.